Great. Well, thank you all so much for joining us today for Return to the Moon, Forward to Mars. With recent spectacular advances in commercial spaceflight, space tourism, and the launch of the James Webb Space Telescope, we're going to retrace how we got here from Kill Devil Hills and Muroc to Cape Canaveral and Boca, Chica. NASA Solar Ambassador David Bell will trace the birth of NASA, our first exploration to the moon, and how going back is a stepping stone to the exploration of Mars and beyond. So David served 26 years in the US Air Force as a flight nurse. He retired as a lieutenant colonel. His deployments included Kosovo, Oman, Tunisia, Germany, and Afghanistan. His civilian work life included roles as an EMT, paramedic, and RN on ambulances and in medical centers. He's also the author of 2 books, and he educates the public on space exploration as a collector of stamps related to spaceflight. So let's give David a big virtual round of applause for his military service, for being a healthcare hero, and for joining us here this morning and donating his time to teach us a bit more about outer space. So David, thank you so much, and you can take it away.
Robert, thank you so much. I want to thank you, Robert, and Tewksbury Public Library, and all the other libraries that have invited people to come and talk about the history of spaceflight. And what I'd like to talk about today is our history of how we got to the moon and going to Mars, and the exciting things that are going on. And I don't know if you can see my T-shirt, but I just got a shirt that's got the Webb telescope on it. And I'm so excited. I've not been so excited about space since I was 10 years old and I watched Neil Armstrong walk on the moon. Some of the things that NASA is doing now and commercial space is doing is just so remarkably exciting. And I hope that you come each month to the library Zoom calls to see the things that are happening in space flight. So what I'd like to do is share with you a couple of slides. Let's see if people can see this. All right. Well, hopefully you can see this screen.
We can see it, David.
Oh, excellent. Okay. First question that comes to my mind is why explore? What practical benefit is there in leaving home and going someplace else? And so I want to look back at something that at the time was just inconceivable. So this is during the Civil War, and Abraham Lincoln is president, and a member of his cabinet is William Seward. And he negotiates a deal to buy Alaska from the Russians. Now, Alaska is not what it is today. It is a frozen wasteland. You can't get there. There are just a couple of Inuits and maybe 1,000 Russians that live in all of Alaska. And why would anybody care about Alaska? Why go there? What's the purpose? And to spend a ton of money, $7.2 million, which was a lot of money at the time, to buy Alaska seemed nuts. So they called it Seward's Folly or Seward's Icebox. Now, if you look at Alaska today, you think, well, maybe it's good that that's part of the United States because that's where we get our seafood from, or that's where we do tourism, or that's where we get oil from. There are lots of different reasons, things that we didn't recognize in 1867, that nowadays we're very pleased that we went out and we did things, that we explored, that we went a little further than our grasp could currently grasp. So what I want to talk about a little bit today is about aviation and space. So there are 2 gentlemen who have a bicycle repair shop in Ohio. And this is around the turn of the century, from the 19th century to the 20th century. And they're following in National Geographic about efforts to create an aircraft. Now, people have been up in the air, but they've been up in balloons. And the interest is in creating something so that man can soar like the birds, that you could be in an airplane. So these guys are following what's going on in National Geographic, and they decide that they want to try to solve this problem too. So they write to the National Weather Service and they say, if we wanted to build some kites or gliders, where could we take it that would have the highest sustained winds that go in the same direction, that's someplace where there aren't a lot of obstructions, like you're not going to run it into a tree? And what the Weather Service said was, if you went to the coast of North Carolina, around Kill Devil Hills, that's where you're going to have the highest sustained winds in the country. So that's what the brothers did. So when they went on vacation, they would take their gliders and their kites and go to Kitty Hawk in North Carolina. And initially, they had their kites, and they're learning about stability and control. And then they made their kites a little bit bigger so that you could actually put a man on it. And eventually, they ended up putting a motor on it, and they created the world's first airplane. Now, before that, people were able to do like hang gliding. So you could have wings and you could run off of a large hill and kind of soar a little bit. But these are people what the Wright brothers did was they were able to go from a stop and to be able to fly straight and level under their own power, and then eventually to turn and to soar and to climb, and they invented the airplane. What's interesting about these guys, and there are lots of things interesting about them. First of all, they didn't have a lot of formal education. They didn't go to college. And they did a couple of things. They were kind of intuitive engineers. They did some things that made them successful. First of all, they had a lot of tenacity. But one of the things that was essential in the creation of the airplane is figuring out about how much lift a wing could generate. And so for this, what you really need are wind tunnels. And these guys are, they got a bicycle repair shop in Dayton. So they don't have wind tunnels. So what they did was they would take little airfoils, which are miniature wings, and they put them on their bicycles and rode them around to figure out which shapes were most likely to generate lift. The other thing that they came up with, and this was brilliant, is okay, so now you've got a wing that's going to generate lift, but how do you make a turn? Well, one of them is sitting in the bicycle shop, and he's taken an inner tube out of a cardboard box, and he's just kind of sitting there with the cardboard box, and the cardboard box is kind of like, well, it's like two wings, right? You've got an upper and a lower wing, and he's kind of playing with this box, and as he twists it, what he realizes is that as the air would come up on the surface of a wing, if you had it twisted, then one wing would be pointed up and the other would be pointed down. And the one that was pointed up, that would generate more lift, and the one that was pointed down would generate less lift. And you would turn in the direction of the one that was pointed down. So that was called wing warping, and that was one of their first accomplishments. Not only being able to generate enough lift to get a man off the ground, but to be able to make turns. So they created the airplane. And the first thing they wanted to do was they wanted to maximize the value from it. They patented it, and they went to the US military and they said, this could be a weapon of war. The thought was that it could be used for military reconnaissance. Now, balloons had been used in the Civil War for tracking troop movements, and the thought was that you could get somebody in an airplane and they could fly around and figure out where the enemy was and that sort of thing. But the US military, the Army, felt that the technology wasn't really mature enough, and they kind of passed on it. So the Wright brothers went to Europe, and the Europeans loved the airplane, and they started building airplanes and having all kinds of meets. And so by the time World War I happened, there were lots of advanced airplanes, and the United States airplanes were not necessarily the most advanced. So what the government did, what Congress did, was they created something called the National Advisory Committee on Aeronautics, NACA. And it's this august group of guys, including Orville Wright. And the kinds of things that they did, they were interested in performance characteristics of aircraft and how to make airplanes safer. And NACA, and that was followed on by the national, followed on with NASA, have been doing that ever since 1915. So here in the lower left, you can see a big wind tunnel, and on the right is one of their signature accomplishments. So you can see these two aircraft. The one on the left, you can see the exposed engine, and the one on the right has a cowling on it, and they call that the NACA cowling. And what they found was that an aircraft that was in a wind tunnel was 10 to 12% more efficient if it had this aerodynamic cowling on the front of the engine. And so they've been interested in performance and safety ever since. Now, in World War II, as prop-driven aircraft would get faster and faster, they started to encounter controllability problems because as an aircraft flies fast, the air in front of it has a difficult time getting out of the way. And if you fly fast enough, you're actually compressing the air in front, and it creates a wall. And that's what the sound barrier is, right? It's compressibility of air in front of the aircraft. So NACA and later NASA was interested in understanding compressibility, the transonic range, and going above Mach 1. So they wanted to create a research aircraft, and they looked to Bell Aircraft in Buffalo, New York. And they decided to come up with a design that kind of looked like a 50 caliber bullet, because we knew that a 50 caliber bullet was stable in flight above the speed of sound. So they created the X1, and this is Chuck Yeager breaking the sound barrier. And that was NACA. That's what they're doing. They're instrumenting this aircraft to figure out how to make them safer and faster and more performance laden. Some of the other aircraft that NASA created are these bathtub ones. They're called lifting bodies. And the thought here is, if you got a plane or a spaceship that went into orbit and you wanted to come back from orbit, there'd be a great deal of friction associated with flying back to Earth. Well, you know that when a meteorite enters the atmosphere, it burns up, and that's a solid piece of rock that's burning. So you can imagine an aircraft that's made out of aluminum is probably going to burn up if it comes from outer space. So one of the thoughts was, well, what if you could have a plane that didn't require any wings? What if the lift associated with the aircraft actually came from the fuselage, the belly of the plane? So they made these bathtub kinds of planes, and were able to demonstrate that you could provide enough lift and actually land these planes on runways without wings. And these are actually the precursors of the space shuttle. And then in the lower right, that's my favorite aircraft. It flew from 1959 to 1968. It was called the X-15, produced by North American. And it had the same performance characteristics as a V-2 rocket. And it flew so high that they gave astronaut wings to these guys who flew it. And as a matter of fact, there were 3 of these, and the third one, the one that did the altitude flights, was first flown by Neil Armstrong, who went on to be an astronaut in NASA. And so around the late 50s, the Russians, as part of the International Geophysical Year, put up a satellite, Sputnik, 1957. And for Americans who are used to being technologically superior, or finding ourselves that way, we're kind of off-put by that and felt, well, we need to jump into this race. We need to put up our own satellite, or we need to put an American into orbit. And then Yuri Gagarin goes up. So the first person in space, first person to orbit the Earth, is a Russian. And so NASA, that takes over from NACA, decides that they're going to hire people to ride in these capsules. And who best to go in these experimental vehicles than military test pilots? So they interview a bunch of guys and they say, okay, you have to have jet time and you have to have been to a test pilot school and pass physical requirements and things like that. And we ended up with 7 Mercury astronauts. And the purpose of Mercury was to put a man into orbit. And so this is 1961, we put up our first guy, and by 1963, the program is over. And actually, before we're putting up men, we're putting up monkeys. And so once we've put up our first astronaut, Alan Shepard, the president, you can see him in the lower picture there, goes to Congress and he says, I think the nation should commit itself before the decade is out of landing a man on the moon and returning him safely to the Earth. Now, Shepard had been in space for all of 15 minutes. Okay, we didn't really have the capability to be in orbit yet, never mind going 250,000 miles to the moon. But he kind of laid down that gauntlet, that challenge. And over time, we were able to do that. And I want to share with you a little bit about, how we got there. So he decides that we're going to go to the moon. And NASA says, well, we'll create this new program. We're going to call it Apollo. But, before we do Apollo, there are a number of different skills that we don't really have yet that we're going to need. So we're going to have to make a program before Apollo. So even though Apollo started in 1961, there's a new program in between Mercury and Apollo. So when you look at the Mercury capsule there in the lower right-hand corner, it has very limited consumables. It gets its electricity from batteries, and the batteries are very heavy. You can just carry so much water. You can just carry so much oxygen. So the limit for the Mercury capsule is just about a day. That's about as much as you can possibly squeeze out of that machine. And yet to go to the moon and back, that takes a week. So we obviously need to be able to do some other things. So here are some of the other things. Came up with a new program called Project Gemini. So Mercury had 1 pilot, Gemini had 2, and Apollo would end up having 3. So what are some of the skills that you need in the Gemini program? Well, one is if we end up having a dedicated lander to land on the moon and a command module, you're going to have 2 spacecraft flying, and you need to be managing in mission control both of those spacecraft. And you need to be able to get them to rendezvous and to dock. And we've never done that. Those orbital mechanics are very complex. And at the time, we didn't have any computers inside the spacecraft. So, and this is not something you can eyeball. So you can see one of the things that we did with Gemini is we learned how to do rendezvous and docking. Now in the lower left-hand corner, that's called a fuel cell. So if you took hydrogen and oxygen and you put them together, you could actually generate electricity. And so fuel cells would be part of the answer to getting to the moon. We needed fuel cells that work. So they use those in Gemini. Also, you might have to go outside the spacecraft. So you needed to be able to do spacewalks. You needed to be able to decompress the capsule, go outside, do useful work, get back in, repressurize. And that was pretty tough to do. And then the one in the middle, that's kind of a funny looking spacesuit. That's a real lightweight, comfortable suit. And that's Jim Lovell in Gemini 7. And so we'd had people in Mercury go up for a couple of hours or maybe a day. But the question is, what would happen to the human condition if we were flying for a week, a month? Would our body, would we have physiological changes? Would it change our vision? Would we have heart problems? Would our vascular system change? And these were legitimate questions. So they sent up Gemini 7 and they sent them up for 2 weeks. So this is two guys sitting in what's the size of a phone booth for 2 weeks. And they finally splash down, in the ocean to be rescued by the Navy. And Frank Borman looks at Jim Lovell and he says, well, do you want to pass out or not? And obviously, they did fine. We do find that over time, people that are on the International Space Station, if they don't exercise, they do become debilitated. There is a toll that's associated with not being exposed to the gravitational forces that we normally have on Earth. We also had to come up with a tracking network. So in the upper right-hand corner, you see two astronauts that are being recovered by the Navy, and that's David Scott and Neil Armstrong. And they had gone up into space and they rendezvoused and docked with a Gina test vehicle. And they ended up having a problem. One of the thrusters on the spacecraft was stuck. They had to disconnect and they were rolling all over the place. And they did an emergency reentry. And instead of landing in the Atlantic, they ended up near Okinawa in the Pacific. Now, in the Mercury program and the Gemini program, it was not uncommon to have 30 or maybe 40 ships associated and maybe 10,000 sailors involved in rescuing these guys that would come down by parachute. And clearly, well, I mean, a good example is John Glenn's flight in February of 1962. The weather was really poor. And so for a couple of weeks, you'd have the Navy just kind of sitting out there waiting for John Glenn's flight, even though it was only going to be a couple of hours. So they clearly had to be able to do more than have 40 ships and 10,000 guys waiting for these two guys to come home. But it was obviously important here, and a ship was able to get out to David Scott and Neil Armstrong and rescue them. So we're talking about going to the moon, and there are people that have been thinking about it for a long time. So on the left is Vernavon Brown. He was an aeronautical engineer, a German, who did work for the Nazis, creating the V2 rocket. And after the war, he was brought to the United States, and he ended up working for us. And he was the one who was responsible for the booster development for the Saturn V rocket that was able to get us to the moon. So one of the questions is, do you build a big rocket and do you fly it to the moon, have it land on the moon, and then fly back? Well, that's very inefficient, because every pound that you lift, you need to have fuel to lift that pound. So really the most efficient thing you could do is lift off the ground with some real powerful engines. And when you run out of that fuel, drop that stage so you're not carrying that weight. And eventually, by the time you get back, all you have is just the capsule with the guys in it. So that's what they did. They created a staged rocket. And instead of having the vehicle that goes to the moon land on the moon, they created a dedicated lander called the Lunar Excursion module, or LEM. And they ended up shortening it just to LM. And that landed on the moon and then would rendezvous and dock with the command module in orbit. And so there were really, in around 1961, 1962, there were three competing ideas of how this could be done. One is direct descent with the Nova rocket, where you take this big rocket and you take it to the moon and then bring it back. And that's not very practical. Then there's something called Earth orbit rendezvous, which von Braun liked, where the lunar module and the command module would be meeting in Earth orbit. And the third idea, with John Humboldt in the lower right-hand corner, is the idea of an orbital rendezvous, but doing it around the moon. Now, initially, when people looked at that, they thought, this is pretty sketchy, because you're 250,000 miles away and you're trying to do these docking maneuvers so far away from homes, where the communication may be poor with mission control. But it turns out that was the best alternative, and that's what they did. And so we get to the moon in the late 1960s, and 24 men went to the moon. 12 of them walked on the face of it. And, over the course of, 11, 12, 13 didn't make it. Then it was 14, 15, 16, and 17. And they did a lot of science. But I have to tell you, in 1972, so this is what, 2.5 years after we finally made it, I see the newspaper heading when Apollo 17 is going to the moon, and it says, last moonwalk of the century. And I'm thinking to myself, we just got there. Why aren't we going back? But that's exactly what happened. We had the capability to walk on the moon 50 years ago, and we don't today, but we're going to get it back. So what did we do on the moon? Well, a lot of different kinds of things. We were understanding things about moonquakes and about, they're called mascons, about different variations in magnetic anomalies associated with the moon. We looked at the moon rocks. We put up a laser rangefinder so that you could send a pulse. It would hit the mirror and then bounce back, and you could time it and figure out exactly what the distance to the moon is. A lot of different kinds of instruments, and we're continuing to study the moon today, even though we haven't visited it there for some time. And the ability to do the science, in large measure, has to do with a commitment to fund it. So in here you're looking at a chart of countries and how much they spend on science. You can see that some of them, like India and Russia and China and the United States, have put some serious money into it. And those countries are spacefaring countries. They're going to be out there, and a number of them have. I mean, Russia and China have landed on the moon. In the lower left-hand corner was Israel. They almost landed on the moon. They were in the terminal phase of landing on the moon, and something happened, and the spacecraft didn't make it. On the right is the comparison between government funding and corporate funding. So here you see 1969 to 2009. There really is, that's kind of the governmental space age, right? I mean, it's government that's putting in all the money. And starting in 2009 with Elon Musk and SpaceX, you're starting to see successful launches of business-related ventures. So there's SpaceX, and then there's Blue Origin, and then there's Virgin Galactic and Orbital Science, and there's money and capability that's starting to come into the space arena. So there you've got Orbital Sciences, and what they do is, from an L1011, they air launch their satellite. And on the bottom there's Jeff Bezos, and he's got his Blue Origin company that's doing suborbital. Right now he's doing tourist flights. And on the left is Elon Musk, and he's doing all kinds of fantastic things with Falcon Heavy and some of his newer ventures. So what I want to talk about is, what's the next step? So, we have this emerging technology, and we have this interest in exploration and always the science of what can we learn? And we've got our International Space Station. We're developing new boosters. Well, I mean, one of the next journeys is for humans to go to Mars. And we can do it, and we're going to do it. And since the 1960s, we've always said we can do that in 10 to 15 years. And that's always been true. But it's a question of, when do you start that clock? Because we never really put the funding in it the way we did with going to the moon. So you have to make a commitment. Lots of these things have long lead times, and they're tough problems to solve. And I want to just look at a couple of those problems. So now we've been to Mars. We've been there a number of times. These are some images from one of the rovers. We landed, had a soft landing in 1976. And now we've got a little helicopter on Mars. So we've got some really good pictures, and we've got some good science, but we can do a lot more science if we explore it on foot. But here are some of the issues. It's not just a question of having a big booster, and one of the big ones is radiation. So it turns out when you go to the moon, you're going there for a week. You're outside the atmosphere, and you don't have the protection from UV rays that the atmosphere provides, and you end up getting an exposure to cosmic radiation, and that damages your cells. It's not good for you. Well, that's a week, but in order to go to Mars, that takes 6 months. So, and we can't just carry a spaceship that's got a big piece of lead in it, because that's going to be really heavy to lift, right? So we have to be thinking about, how do we reduce our exposure to radiation? How do we protect the astronauts? And we're still thinking about those kinds of things. So over on the right, you can see the one that says number 1, which is that tiny little sliver. That's if you just got a dental X-ray. That's how much radiation you get. And all the way over on the right, number 9, that's if you had 9 days on the moon. Well, going to Mars would be a lot of radiation, and we still kind of working that issue. Another one is breathable air. We can't really take 6 months worth of oxygen cylinders with us to Mars. And even if you did, then you'd show up to Mars and have nothing to breathe. So we need to be able to manufacture our own air. Now, one of my friends who's a solar system ambassador, we're both volunteers with JPL. He works on a program that's a prototype that's on Mars right now called MOXIE. And MOXIE, it says Mars Oxygen in Situ Resource Utilization Experiment. That's a mouthful. But really, what it's doing is it's a fuel cell, but it's in reverse. So what it does is you can take in carbon dioxide, which Mars has lots of, run it through this thing, and it breaks it down. So what ends up coming out is carbon monoxide, which just gets kicked out of the machine, and it produces oxygen. Now, oxygen is very useful because oxygen is a fuel for rockets, and it's also breathable. So you could send a rocket to Mars with MOXIE, and it would start generating oxygen, putting it in cylinders. And then by the time you got there, you would have all these cylinders full of oxygen. So that's the plan. Now there's the question of power. Now, one thought, we've used this in space a lot, is solar panels, right? The problem with using solar panels on Mars is there's an awful lot of dust. And when the sun's not out, you're not generating electricity. So it looks like what makes the most sense is nuclear power. So for Mars, if you had a solid uranium reactor core, and this is about the size of like a roll of paper towels, you could generate enough power for operations on Mars. So you'd have a series of these set up, and that would be your energy grid. And where are we going to get water from, right? You need water to live. You need water to grow plants. Well, it turns out that there's a good amount of water on Mars. It's at the North and South Pole. And so if we were to go to Mars, when we go to Mars, we'll probably go someplace near where there's water because we're going to need that. And I wanted to just share with you a couple of things that I've read that kind of, well, they speak to me. We choose to go to the moon in this decade and do the other things, not because they're easy, but because they're hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we are willing to accept, one we are unwilling to postpone, and one which we intend to win. I don't think the human race will survive the next 1,000 years unless we spread into space. There are too many accidents that can befall life on a single planet. But I'm an optimist. We will reach out to the stars. I don't know what you could say about a day in which you've seen 4 beautiful sunsets. From out there on the moon, international politics seems so petty. You want to grab a politician by the scruff of the neck and drag him 250,000 miles out and say, "Look at that, you son of a bitch." When I first looked back at the Earth, standing on the moon, I cried. If offered a seat on a rocket ship, don't ask what seat, just get on. The thing I'll remember most about the flight is that it was fun. I'm sure it's the most fun I'll ever have in my life. Our universe is a sorry little affair unless it has something for every age to investigate. Earth is the cradle of humanity, but one cannot live in a cradle forever. How about, do we have any questions or comments? Robert, what do you think?
So we do have a question for you, and I would encourage folks to get their questions and comments into the chat and the Q&A, and we'll get to some of them. So Mike asks, and he asked this right as we started, but I don't think you necessarily answered it. When or if will the US put a human back on the moon, and who will be the first to put the next human on the moon? Which nation or corporation?
Well, I think the United States has committed to putting an American on the moon in 2024 or 25, in the next couple of years. I suspect that somebody like Elon Musk will have people orbit the moon maybe sooner than that. He has some tremendous aspirations and capabilities. So I don't know that a corporation will land on the moon before a government does, but I think they'll be going to the moon a lot quicker than people think.
Excellent. And that question came from Mike, so thank you, Mike. So far, I've just prompted folks to ask some questions and make some comments. And so far, a shy audience, David, but we have...
and that's okay. That's okay
too, yeah.
I'll tell you, it's the stuff that I've been reading about the Webb telescope. I just want to mention that. Absolutely unbelievable. I mean, we have terrestrial telescopes. I mean, we have the one out at MIT and a number, Palomar and all kinds of wonderful telescopes on the Earth. But once we put one in space, which we did 25 years ago, the Hubble Space Telescope, we were able to see things, and it's kind of like a time machine, because when you see light, when you see an object, like if we look at the sun, we're not actually seeing what the sun is doing right now, because that was actually happened 8 minutes ago. It takes 8 minutes for the light from the sun to reach us. So we're looking back in time at the sun, what happened 8 minutes ago. Now, if you look at something that's farther away than the sun, it's also farther back in time. So with the Hubble Space Telescope, we're able to see back billions of years. And to give you an idea, the Hubble is remarkable. It's circling the Earth at about 200-300 miles above the Earth. This telescope that was just launched a couple of weeks ago is 1 million miles away, and it is 100 times more powerful than the Hubble is. And we're coming up with discoveries with the Hubble every day. And this thing that's going to be 100 times more powerful is just going to be remarkable. The things that we're going to be able to see, and to be able to reach back in time further and further towards the origin of the universe is just, it's exciting.
So Bernard asks, has China become more interested in space than the United States? What are your thoughts on that?
Well, when you say more interested, let's draw a distinction between the people and the government. China has been very proactive about space. They have their own space station. They've landed on the moon. They call them technonauts, as opposed to cosmonauts or astronauts. They have a robust program, and they're going to go to the moon, and they're going to go elsewhere. They have a commitment. Their government has a commitment to funding. Whether or not the average person in China or the average person in the United States, I guess I don't understand why people aren't as excited about exploration and what's in outer space as I am. The amount of money that we obligate for NASA is half of 1% of the budget or something like that. And I think of what we've accomplished in this country. When I was 10 years old and we landed on the moon, that was an accomplishment not just for our country, but it was a world accomplishment, and it increased our prestige and the amount of technology that came from not spending money on the moon. You can't spend money on the moon. We spent money putting it into universities and to think tanks and to corporations, and we created technologies, aerospace technologies, computer technologies, healthcare technologies. All the things that we have in the space age were because we needed those capabilities to explore. And to me, we should be doing tons more of that. When I was 10 years old, they say, you could put a man on the moon, but you can't get somebody to cut bread correctly or something. Everything was based on that high watermark. We were saying we can do that. And I think what's going to happen in the next year, once the Space Telescope comes online and you see the kinds of things that we're doing, it's going to be a new high watermark. We're going to look at it and we're going to go, my God, we can do that. Maybe we can do anything. Maybe we can do everything. So I'm excited about that.
Nancy says, fascinating talk, wonderful speaker, thank you. Roberta says, when do we expect pictures and data from the James Webb Telescope?
Okay, well, I'm not sure if it's in place now. I think it's about where it needs to be, about 1 million miles away. And it's in something called a Lagrange point. And what that means is that, every object exerts a gravitational force on every other object. You and I exert a force on each other, but because neither one of us is terribly massive and we're far away, the amount of pull is minor. But obviously the amount of pull between like the Earth and the sun is considerable. And if you orbit something, if you put like the Hubble Space Telescope up, it's going to get pulled by the Earth. But because it's running so fast, it neither flies off nor falls down. So it continues to orbit. Well, it turns out that there are a couple of places in our solar system where if you put something in an orbit, it will have about as much pull with the Earth and also with the sun. And it requires very little energy to stay in that place. And that's called a Lagrange point. Well, there's a Lagrange point on the other side of the sun. There's one between the sun and the Earth. There's one on the backside of the Earth. And so L2, where this thing is behind the Earth. And so really what we want to do is we want to block out all the light from the sun, but we also don't want to use a lot of fuel to move around. So this place, Lagrange 2, it's just about there. If it's, I would imagine this week or something, it's going to show up. What they're doing now, the thing is kind of unfolded. It was kind of an origami thing. The mirror was so big, it couldn't fit into the spacecraft. They had to fold it. But once it's all unfolded, they need to align the mirrors. So it's probably going to be about a couple of months, 3, 4, 5 months until we get some great pictures.
Next time I go to the doctor's and the doctor questions me about my weight, I'm going to tell him, hey, at least I'm not terribly massive, right? Or something. I'm going to use that line. So Karen says, and Karen, we'll be talking about this next month with Regina. Karen asks, how serious is the problem of space junk? And maybe China should stop blowing up their old satellites for practice.
Yeah, space junk is a problem. It depends on the elevation. There are certain orbits that have a lot of stuff in it and other orbits that don't. So for example, if you were in geostationary orbit, which is way the heck out there, the likelihood that you're going to get hit by something is very small. There are other orbits where people have put up satellites and they're spent boosters running around that are a problem, and all the time the International Space Station gets hit by stuff. And it's not necessarily very, very big. It could be like a fleck of paint, anything that if you have it running fast enough could be like a bullet, and it could put a hole in your spacecraft or knock you off course or something like that.
Yeah, so let me stop you there. A semi-related question from John. There are a lot of satellites in space. What is being done to prevent these from crashing into each other?
Well, they all have their own orbits. Okay, so they're not necessarily catching up with each other. They rarely, space is pretty big, so they rarely run into each other. But like I said, in the same way that on your radio, you can have a number of different stations that are very close to each other and they can kind of conflict. Same thing with orbits. In certain orbits, at certain elevations, there's a lot of stuff. And eventually that stuff is going to fall to Earth, or we're going to have to go and clean it up. And we might have to do some of each.
And to tie some of these questions together, Phil says, thank you so much for the informative session. I'm very interested in understanding the threat that so many of the microsatellites that SpaceX has launched will cause for potential space junk issues, but also issues with our ability to observe the night sky.
Well, let me take the first part first. And there were some complaints with SpaceX because their satellites were shiny, and it was spoiling, the ability to observe. And so what they've done is I think they coated them black or something like that. So they are being responsive to that. It has been an issue. It is a problem. In terms of running into stuff, I don't know that any of their satellites, and they've put like their first orbital shell together, and I think it's about 600 satellites. It hasn't been a problem yet.
Mike has sort of a follow-up question from his first question. Which is more likely to fund a Mars space travel? Competition between countries like the US versus Russia, or spreading the cost among many countries like the ISS?
Well, the problem with spreading it amongst countries, we can't agree in the United States on what to do. The likelihood that we're going to get a number of countries, I mean, I'm amazed that the ISS works, that we're able to have the European Space Agency and the Russians, and that we're able to get that stuff done, but we do. I think what's most likely in terms of like getting to Mars, I think the first people to Mars could be Elon Musk, could be somebody with a singular vision, somebody who has resources and says, we're going to do it. So it might be commercial. It could be NASA.
Kathy says, great program, great speaker, can't wait for more. Barbara says, a lot of information and lots of things to look forward to. Thank you. Jody says, excellent talk. You made it very clear. Thank you. Teresa says, thank you for this very interesting presentation. Phil asks, isn't the Webb telescope also an example of international cooperation?
Well, it is. It is. And international cooperation goes back a substantial amount of time. If you remember the arm that came out of the space shuttle, it had a flag of Canada on it called the Canada arm. And this articulated arm, which allowed you to put satellites into space and do all kinds of stuff, was technology that that we got from the Canadians, and we're constantly putting up satellites and different kinds of sensors and working with different nations. I don't mean to suggest that everything that we put up is just ours, only to suggest that big projects, things that take a long period of time, are tough to fund. They're tough to get a kind of a long-term commitment and a vision about what we're trying to accomplish. That can be tough.
And we'll get you out of here on this fun question. Teresa wants to know, do you ever plan on going up into space?
Well, I didn't think, particularly after 1972, when they said, okay, that's the last spacewalk of the century. I'm like, really? 28 more years and we're not going to do anything? I didn't think that would ever be a possibility for me. But nowadays, now we're seeing with space tourism and things like that. I mean, I don't have any interest in going to the moon, but if somebody invited me to go up to the International Space Station and kind of hang out in the cupola for a week and watch the Earth go by, I think that'd be pretty cool.
So I think, David, we'll wrap it there. I don't see any more comments or questions. Just want to, before I give you an opportunity to give any last words, I did want to quickly plug our next program in the series, Friday, February 18th at 11 o'clock, Asteroids, Comets, and Near-Earth Objects with Regina Conrad, who's sort of a NASA Solar Ambassador colleague of David's. And really looking forward to that one. And for folks who are watching live, when I send the recording and the feedback survey out, I'll also include a registration link for that program as well. So David, any last words before we wrap up for the afternoon?
Well, Robert, thank you so much. And I'm so grateful that people came to the talk and that were engaged and had all kinds of useful questions. I think that's tremendous. I think that's what's going to get us back out into the, into outer space again is public interest in space flight. The one thing I would ask people is I want you to hound Robert and tell him that you want me to come back and talk about the Hubble Space Telescope. And I know he's got several people lined up, but if he can put me in the spring or something like that, there'll be all kinds of interesting things to talk about. And I'd love to come back and talk to you.
Yeah, consider it done, David. Absolutely. We'll make that happen. All right. Well, thank you all so much for joining us. Another big virtual round of applause to David for giving a wonderful presentation. And yeah, I hope everyone enjoys the rest of their day. And I hope you join us for some future NASA Solar Ambassador presentations. So thanks again, David. And I hope everyone, like I said, enjoys their day.